In this lesson, we will sketch the graph of a rational function with a slant asymptote. The function is g of x equals x cubed minus 3x squared minus 4x plus 12 over x squared minus x minus 2, and we'll begin by determining the domain and any holes. To determine the domain, I'll start by factoring g of x into x minus 2 times x plus 2 times x minus 3 over x minus 2 times x plus 1. Note that our domain will exclude the values of x equals 2 and x equals negative 1, so the domain will be negative infinity to negative 1, union negative 1 to 2, union 2 to infinity. And also note here that x minus 2 is a factor of both the numerator and denominator. So actually x equals 2 will be a hole in the graph. So the hole's at x equals 2. Let's simplify g of x a bit. Let's write it as x plus 2 times x minus 3 over x plus 1. Making a note that x cannot be equal to 2. And then let's find the y value at that hole using this simpler version of g of x. At the hole, y will equal 2 plus 2 times 2 minus 3 over 2 plus 1. So we'll have a y value of negative 4/3. And my hole will be the point on the graph of 2, negative 4/3. Let's next find the x and y intercepts. To find the x-intercepts, we set g of x equal to 0. 0 equals x minus 3 times x plus 2 over x plus 1. And my x-intercepts will be at x equals 3 and x equals negative 2. Y-intercepts occur when x is equal to 0. So for y-intercepts, I'll have 0 squared minus 0 minus 6 over 0 plus 1. We'll have one y-intercept at the point 0, negative 6. Let's next find vertical asymptotes of the graph. Vertical asymptote, I'll have 1, and that will be when x plus 1 is equal to 0. We will have the line x equals negative 1. That is our vertical asymptote. Do we have a horizontal or slant asymptote here? The degree of the numerator is 2. The degree of the denominator is 1. With the degree of the numerator being 1 more than the degree of the denominator, we have a slant asymptote. To find the slant asymptote, I'll take x plus 1, divide that into x squared minus x minus 6. X goes into x squared x times x plus 1 is x squared plus x. We'll subtract and get negative 2x minus 6. X goes into negative 2x, negative 2 times. Negative 2 times x plus 1 is negative 2x minus 2. Again, I'll subtract and have a remainder of negative 4, which we don't really care about. For the slant asymptote, all we're interested in is the quotient of x minus 2, and so my slant asymptote will be y equals x minus 2. Let's next determine the behavior between the x-intercepts, vertical asymptotes, and holes. Here is a number line that I will use for a sign chart. My x-intercepts are at negative 2, 0, and 3, 0. So we'll mark the x values of negative 2 and 3 here, and their associated y values of 0. The vertical asymptote at x equals negative 1, I'll mark on my sign chart. And I'll put a frowny face here because we know when we have a vertical asymptote, there are no y values at that point. We have a hole when x is equal to 2, and I'll mark that with an H. And then recall g of x equals x minus 3 times x plus 2 over x plus 1. And to determine the signs in the different intervals here, the signs of y, I will plug different test values into g of x. I've already done that, and so in the interval from negative infinity to negative 2, y values will be negative. In the interval from negative 2 to negative 1, y values will be positive. From negative 1 to 2, negative y values. From 2 to 3, negative y values. And from 3 to infinity, we'll have positive y values. Let's next sketch a graph of the function. There is a hole at 2, negative 4/3, so I'll start by putting a hole on my graph. The intercepts are at negative 2, 0, 3, 0, and 0, negative 6. I have a vertical asymptote of x equals negative 1, so I'll sketch the line x equals negative 1. And I will sketch the line for the slant asymptote of y equals x minus 2. Okay, and let's use our sign chart to help us see what's going on. To the left of negative 2, y values are negative, so we'll be below the y-axis, or below the x-axis. From negative 2 to negative 1, my graph will be above the x-axis. From negative 1 to 2, my graph will be below the x-axis. And then we'll continue below the x-axis till we get up to x equals 3. After that, the graph will be above the x-axis. And note that we are approaching asymptotes as we draw the graph. So this is the graph of the function. Try on your own. Find the domain, holes, x and y intercepts, vertical asymptotes, horizontal or slant asymptote, and sketch a graph of the function f of x equals x cubed minus 2x squared minus x plus 2 over x squared minus 2x.